everybody. Thank you for being here. Thank you for your interest in preservation, restoration, and protecting legacy for the future. Stanford Sandstone. Originally it comes from Goodrich Quarry. First owner of the quarry was Levi Goodrich, acclaimed well-known architect from San Jose. Quarry was located near San Jose, Santa Teresa Hills. Second owner was master stone cutter Jacob Pfeiffer. Mr. Leland Stanford built railroad to deliver sandstone blocks from the quarry to the main quad. One of the significant costs for stone work, for stone construction, that was transportation, because everything was done by horses at that time. So he definitely, with his railroad background, it did help out to build railroad and bring stone right to the site. In 1893, Leland Stanford died, and all his funds were frozen for 5 years in court. Then, after they were released, James Stanford started huge construction at Stanford University, stone construction. She did hire John McGilvray, well known for his work at San Francisco and Denver. McGilvray comes from generations of stonemasons, originally from Scotland, and his impact on California, specifically stone industry, was enormous, because besides the building stone market in California, he also built and brought new standards for architectural stonework. And he was actually living right here at Stanford. He had extended family. 3 of his sons graduated Stanford University, and they did prolong his business. And that family actually was also owner of one quarry in Calusa, California, Calusa Sandstone, well-known sandstone, many buildings built up in San Francisco. One of them, perhaps biggest one, San Francis Hotel at Union Square. Also Presidio Park, all their gates. And also later they got granite quarry in Madera County, California, Sierra White granite, which one we can also find here in Stanford. This is the granite I'm standing on. All stairs around main quad made from this granite. And this particular quarry, right now it calls Raymond Quarry, is still be in operations. It's still producing stone, and will still be available on California and US market. Stanford sandstone, it's kind of an unusual sandstone, specifically regarding to its color. There's many different types of sandstone, and some of them actually even presented here. If you look at the main arch and rosettes on the top, which one contain few different sandstones. Dark gray, greenish one, that's a Calusa sandstone. It's a local from California. The brown reddish one, that comes from Pennsylvania, from East Coast. That stone actually well known on East Coast, specifically in New York. If you ever heard brownstones in New York, they built from that sandstone. So there is no other stone like sandstone which one has such a high absorption rate. Even concrete, or let's say Indiana limestone, it has about 7% of absorption rate. By the way, this is actually carved in Indiana limestone. Indiana limestone considered to be #1 stone in the United States for construction and carving. A lot of buildings on East Coast, some of them you might know, Empire State Building, every second building on Fifth Avenue, or National Cathedral in Washington, or Pentagon Building, and so on, so on, or Chicago, brick and limestone, that's Indiana limestone. By the way, Indiana still have 8 quarries which one still be in operations. They still produce stone, which one available for construction, for carving, and so on. Sand and sandstone. Yes, they do have actually a lot in common because sand is pretty much quartz. That's what glass made from. And glass actually on the scale of hardness for natural materials is 7 points. We're talking about Mohs scale from 1 to 10, where the like number 1 it's a talc, and number 10 it's a diamond, the hardest natural material. Ruby is 8, emerald is 9, sand, glass, it's about 7 points. So that's why actually some people think sandstone is a soft material. Yes, in some degree it's true, but on another one, when you work on sandstone, your tools getting dull very fast, like almost like you're working on granite. Even carbon tip tools. Why? Because again, so much quartz inside of it. For example, same tools on limestone or on marble, it will last 10, 20 times longer without needs for sharpening or so on. Regarding sandstone, because it has high content of quartz, it's actually natural abrasive. You can sharp tools on it. You can sharp, you can sharp steel chisel, not carbide, but steel you can do. And also sandstone actually used as abrasive on marble. It's a great abrasive. You can use it with water and it sends it down surface to nice honed surface finishing. And I would like to show you actually some of our work on site right here. All these bases on the bottom of the columns, it is Stanford sandstone, over 30 million years old one, but this is actually fresh work, which one was done about maybe 6 years ago or so, because the original one was very badly deteriorated. Pretty much main cause is the water, and mostly just from rains and flashing over the stone surface. So what we did here, we removed all deteriorated surface and we placed new pieces of sandstone about 3-inch thick. And if you will pay close attention to it, you might see the joint. And actually here is a one large piece, thickness of 3 inches, which one was placed around all bases. Structural integrity is still be there, and actually natural stone, which one actually deeply inside, is still be in good condition and is still holding fine. Also, besides the basis of the column, some work was done over the torus of the column, over the molding, and if you look close, you might see these joints, which one means that's actually those implants I was talking about. So deteriorated material was removed and new pieces of stone were installed. Beside the stone replacements, there is some, in some cases here we can see composite repairs, like here corner and here too, this corner too, that's composite repairs, this corner too. This is kind of a typical yellowish color of the stone, but in this case it's actually kind of a gray. This is a natural one, but this part, it's composite repair. But here on this side, even more of it. And on this side, actually, it's much more kind of a match in the color. But you can see, because this small, let's call it island, that's a natural stone. But what's around it, about 85%, that's all composite repairs. but the tooling, which one was originally on original stone, it's brought up also here, and it exists also here, and hopefully public will not even notice our work here, and I think it's a good thing. I take pride for it. And talking about deterioration, this old stone, do you see it's still be deteriorating? And if you look close, right under the torus, there's grains of sand. Grains of sand, and we cannot really stop deterioration, but we can prevent it. We can slow down it. And basically, first of all, just taking care of it and try to prevent it from water intrusion. All these bases, it's a new stone, but every time when we do the work, we pay attention to details like, for example, tooling or surface finishing. This tooling match exactly as it was done on original ones. Stanford has tremendous amount of surface finishing, most of it done with a teeth chisel. It calls teeth chisel. There is a second name for it, claw chisel. And you can see marks of those chisel everywhere. And actually, in some cases, even like they were using different size, which one does show different lines, marks of the chisel. Also, it gives not just texture. This texture also starts to interplay between light and shade, and you can see material in much more kind of a greater way than it would be, let's say, only one honed surface, something like flat and smooth. And people who was working with stone here, including probably under guidance of architects, they knew about it. So they were using it everywhere. You can see chisel marks here. You can see here they're like in vertical way. Here they're in horizontal way, and definitely different size of the chisel was used for that. Even in carving floral elements, also you can see those claw chisel marks. It's a beautiful because it's done by hands and by hand tools, and we can see this craftsmanship, and which one does show the beauty of the natural material. Most of the carvings, what we see here at Stanford, we can call it architectural carving. What's mean architectural carving? Architectural carving, which one, that's a good sign. Architectural carving, which one require drawing. You follow the drawing. Also, to do the architectural carving, it's usually require some measure tools, like a square, like a straight edge, like a compass. Besides stone carver, I'm also a sculptor, but with a stone carving experience, and specifically in architectural carving, it's actually also doesn't allow you some kind of a freedom, what you might know, like in things like, if you ever heard direct carving. Direct carving, it's something what's kind of invented by amateur sculptors who likes come to block of stone and figure out what's inside of it. Well, first of all, work with stone, it takes time, take persistence, and usually you need to know first what you want to do. But with architectural carving, it's everything strict. There is certain measurements because it's a number of blocks. They're all supposed to be put together. Everything's supposed to fit. And even these floral carvings, what we see here, the story is Jane Stanford was checking out the depth of the carvings using a tip of her umbrella. I don't know if it's true or not, but these Romanesque carvings, repetitive ones, they require, for example, to have a template to do something like this, which one can be used. You don't need measurement tools really for that, but you still need to have something for reference. Also, many designs are kind of repetitive, like for example, columns, capitals, they have few designs, 4 or 5 of them, which one repeats. But in some cases, specifically here at the church, there is some stones, which one, I can show it to you here in the middle of the, do you see these small stones, looks like corbels? If you look at the designs on them, because I spent here a number of time, there is no repetitive design. They're all unique. All of the stones with a small design. Some of them like this guy, it looks like it's a green man design. Next to it, some kind of a leaf. This is some kind of a flower. This one kind of reminds me Medici sign, Medici family, but they're all actually here different. I don't know how to explain it, why, but probably in some actually cases, sometimes people who is building things like this, specifically for stone carvers, they got freedom. Usually they got freedom, like even from architect. You can do your own design wherever you feel actually what works here. Yeah, Memorial Church probably has most of the stone carving around here, around Stanford. Also, it's a kind of a signature of Richardsonian-Romanesque because they very often put together architectural carving with a rough stone, which one actually calls split face stone. I'm talking about this roughness, which one actually was done just by chisel and hammer splitting it, but it gives contrast of dressed stone, like this molding, egg and dart molding, which the repetition always gives movement to the carving, to the moldings. Regarding surface finishing and tooling, this is what calls teeth chisel, and kind of obvious why it calls like this. And they can be different in size, and basically they can give you different texture, a similar one. And some of them it's like for very fine work, something like this. That's what we see, for example, here on the body of the column. Actually, well, you see it everywhere. That's done by hand chisel. Here they did probably, we're using more, not chisels, we're using rasps. Basically, it's a sanding device, something like that. In this case, it has a carbide, and you can sand it out on the sandstone and make grooves. Talking about rasps they design actually for surface finishing on the stone. And this is actually something like straight. It's definitely for architectural carving, but they come actually in different shape and sizes. Like for example, something like this. This can be used even on many other stones, even actually can work on wood. It's a steel, it's forged steel. But this rasp, for example, it's already kind of today's technology because this is actually diamond. It's a diamond tools. It can work on any material, including sandstone. And when it comes to surface finishing, if you want to bring and do the texture, something like what we see here, that was done by teeth chisel, something like that. What we see texture here, that was done by point chisel. Point chisel, it's actually, as a name say for it, it just has a point. But in some cases, actually, for mostly actually for bush hammering, there is 3-point, 9-point, 12-point chisels. They also exist, and they're actually more designed for power tools, air gun or pneumatic hammer, which one made huge revolution and basically speed up the process specifically for stone cutters and stone carvers. It just helps to do work faster. So it's eliminate something like this. This is a mallet, which one actually specifically great for architectural carving when you need to do something continuous, something like molding, for example. Smaller hammers like that, they are great for detail work or something like hand-carved lettering. And actually, they use a soft metal, so when you work with a chisel, so it doesn't bounce. If you have very strong metal, it bounces. But soft metal, it's kind of more gently and absolutely different touch. Also, today's tools, besides the forged steel, which one used to be before, something like this is called gouge. Now we have carbide tips, which one actually, it's not really steel, it's wolframium and cobalt together, but it's extremely hard metal, which one specifically used on granite. And actually talking about bush hammering, this surface of the granite, that's a bush hammering, which one basically point chisel, but many of them kind of together. And they provide this textured surface. Yeah, and talking about rasps, they also, even they come in different shapes and depends on work what you do, but different grid and different size, because it's very often also used on sculpture to do the sculpture, like specifically when you, if it's a statuary and you do, let's say, face and hands, which one requires some sanding, and basically rasp, they're kind of like a sandpaper, but sandpaper also used in stonework, specifically on marble for sanding it down. Around Stanford here you can find some traces from drilling tools. For example, on this piece you might see, basically you drill holes, then you set up wedges and shims, you add to it pressure by striking tools, by hammer, and you can split the block of stone. That's how it was done 100 years ago, and actually that's how it still be done even today. Yeah, and in some cases here it's left, and it left, I'm pretty much sure on purpose, because people just didn't want to hide the work. They wanted even to show how it was done. But it was done much more of that than you can see. Here just like kind of left like in few places, but actually when you split the tools, especially before the diamond tool showed up and using diamond, so they were splitting blocks every time like this, drilling the holes, setting up shims, feathers, and striking it by hammer. And so talking about architectural carving, this is kind of a today's artwork, but it's all based on traditional methods of architectural carving. Look at all these straight lines. Of course, to do something like this, you need to use measure tools, you need to have drawings and so on. Something like this is more like a free carving. All sandstones, they more or less have same problem when it comes to deterioration. Sandstone, primarily mineralogical content of this stone is it's quartz and feldspar, about 80%. And the rest, 20%, which one works like a binder, it's a clay, which one has some minerals like calcite and limonite, which one are soluble in water. That's one of the problems with the sandstone, specifically when it's exposed to the water, why it starts to deteriorate, because those soluble minerals, they just washed out, and they are weaker binder, which one holds the quartz grain, and deterioration starts with. And clay also, when it gets wet, it expands in its value, in its size, which one leads to swelling, cracking, and spalling. When we restore lost architectural fragments of architectural carving or deteriorated things, whatever happened, usually we use two different techniques for it. One of them it calls stone replacement or Dutchman. What it is, it's like, I will try to do analogy, like when you go to dentist and your tooth is broken and they place a new implant, a new piece. Same kind of more or less happening here. When a piece of the stone deteriorated, lost its structural and aesthetic integrity, we do replacement. Replacement, for example, here's some hand-carved pieces of moldings, of bases of the columns, torus, and pieces like this. To do that, we remove unsound material, remove deteriorated stone, create a niche. We carve a new piece which one fits and repeat the previous shape and place it usually with stainless steel pins and epoxy injections. This is the one technique which one helps us to restore. There's another one which one calls composite repairs or composite patching, which one based on mortar. Mortar has content of Portland cement, about 15%, but main aggregate it's actually sand. Depends on what kind of a mortar it is. Quite often it's a combination of cement and lime together. In old age times, before Portland cement was invented, most cathedrals in Europe, they were using lime-based mortar, which one usually was 1 part of lime putty and 3 parts of sand, which one was mixed together by hands. And that mortar actually, even if it's soft, but it's also flexible, and those cathedrals, they still stay for centuries or even millenniums because they are allowed masonry to move and to breathe, because we don't see it by our human eye, but we do know all this structure. They contract, expand, they move. Depends on the weather condition, depends on the temperature, and so on. For composite repairs, here specifically at Stanford, we use usually, or in most cases, a product which one calls, which one produced by Cathedral Stone Products in Maryland, and it calls M70. M70 is specifically designed for sandstone, which one has very close physical properties as a natural stone. For example, natural sandstone has very high absorption rate, about 16%. Our mortar has absorption rate 14%. That's very close. For comparison, granite has less than 1% absorption rate. Marble has about 1-2% absorption rate. And here's just some examples of mortar for composite repair, different colors, different textures. Here's some samples of mortars which one we do on architects' request for specific projects, match the color or match the texture. On most historical mortars, actually, the sand is kind of rough and large in grain. And we use for our mortars Monterey sand, which one is washed, kiln dried, and also it's kind of a close to the sandstone in color, which one kind of an important thing, even if you use pigments in your mortar. In some cases, even like there's some presence of reddish veins and so on. So some of them like more juicy on yellow color, some of them actually more pale. And we're trying to pay attention to this and be selective regarding color and trying to match. And our goal is to make our work as less visible as better, so it's not so noticeable. The color can be affected just even moisture in the air. It depends when you do the work, and especially here in Palo Alto, especially like at winter time, sometimes like in the morning, the humidity 90% or even greater. Like now, like on middle of the day, sunny, it can be 30-40%. Even that amount of moisture in there, it can affect color of our composite repairs. So like even you use same mix, but it can look slightly different here and slightly different there. Difference is very not significant. It's kind of even hard to notice it, but actually it does happen, yeah. We're talking about Balustrade, which one is located right in the front of the main quad. This is a single largest structure, yeah, this one, which one actually exposed to, and under open sky. It's exposed to all elements, specifically talking about rains and sun. Plus, it was actually exposed to irrigation system for sounds like a number of years, and now we know sandstone doesn't like water. Well, unfortunately, it doesn't have a roof. We cannot protect it from rains, but now there's no irrigation system. It doesn't pour water on daily basis. Basically, when sandstone going often through wet and dry cycles, deterioration speed up, accelerates dramatically. There were a number of balusters which were missing, capstones were missing. There was a number of displacement. Here's the balustrade, and you can see when we actually start working on this, that was already a safety issue. Some balusters, they already were so badly cracked, they just were collapsing. And when we started actually removing them, they started collapsing just in our hands. We actually had requests like, okay, can we maybe save some of those balusters perhaps as a gift for donors or something like this? But it was impossible because actually they were even like in worse condition than we saw. They actually like, when you start just moving it out, it just break on parts. And the sand just like goes down like that. There was a number of spalling, a lot of spalling. This is actually from Balustrade. This is right by the main entrance. To do something like this is about maybe 5 square feet area. It was done with M70 composite repairs. It's a large but shallow, just maybe about ½ inch patch. It's still be intact, it's still holding well after 16 years. Yes, there is some hair cracks on it, but we do know concrete-based materials, they do crack. That's why they place reinforcement in them. We don't have any reinforcement in it, but it's still holding well and still perform quite well. So all these spouls, which one, and material, which one gone, we did restore it, we did place it back. This is actually also working over the balustrade. And by the way, what you see here, these damages, that's from pressure washer, because sandstone actually, it's a sensitive. And today's pressure washers, they can be 5,000, 7,000 PCI, and you can easily damage a sandstone if you don't know what you're doing. And this discoloration, they did try previously a number of times to prevent deterioration. Looks like probably some consolidants were applied before, which one changed the color to dark color because they were affected by UV light. That's my speculation, I don't have proof for it, but that's what I think so. Which one can be used, but it can be used indoor. Unfortunately, when structure is outside, outdoor, water still finds a way to get inside of it. And when you have something like sealers or consolidants on the way out, it breaks everything. Doesn't matter what's on its way. So Sometimes, yeah, we do work with some discoloration. Discoloration can be ferrous stains. There was a lot of them from iron anchors on the top, biological growth, or perhaps graffiti, but we didn't have much graffiti in this way. Plus, also some capstones, for example, you can see fracturing here, cracks. Some of the capstones, they're about like 800 pounds each, but some of them were cracked, and cracked like on 2 parts, on 3 parts, or even some cases 4 parts. So we removed them, we turned them around, upside down. We provided reinforcement, huge 1-inch diameter threaded rods, stainless steel, embedded in channels with epoxy, so they can hold all those deassembled pieces back again like a one piece. Then we repaired the cracks, and now it's performing quite well actually after 16 years. There are some issues still happening again because that structure cannot be protected from the rains, but we can always get back to it and improve wherever need to. But main thing is just, yes, trying to keep away water. We do deal with things like graffiti, biological growth, or ferrous stain removal. Usually it's required chemical cleaning. We use chemicals and nylon brushes, sometimes also pressure washer to remove it. And because sandstone is very porous and usually paint penetrates quite deeply inside of it, so in some cases it might be challenging to remove it. And the traces of those challenges are also nearby. If you look back to the arches, and specifically on the right side of this arch with a floral carving, and next to it, do you see the color over there, kind of like not really sandstone, kind of pinkish a little bit? That's actually painted sandstone. It's painted because probably they had problem with graffiti over there, which ones they had difficult time to remove. And also for maintenance purpose, they just painted it, and perhaps it was painted maybe 30, 40 years ago. Now, they painted trying to match the color of sandstone, so it's not noticeable to others. But because it's staying over already a long time, UV light deteriorates the paint slightly starts changing the color. But sometimes it can be very challenging to remove. It takes a number of applications. Yes, I was working on them, not just me, it was team effort, Stanford architects, Stanford archive, with all their support. We, based on historical photos, what we were able to find out, any other additional information, we decided to recreate those Mason statues. That's how it was done. And we choose for them Clara marble, same material as it was done originally. Also, based on those photographs, we were able to see the silhouette of the statues. We knew who it is, and we were able to find more additional information. And actually, this is models which one we use in creation of those statues, just different scale, because this is actually 1 meter, but our statues is 2.5 meters. So the ratio is 1 to 2.5. You can do it in stone. You can do in stone enlargement or even reduction by using actually measure tools. You cannot do it in bronze. Like for example, in bronze, you can do it model to transfer to final piece must be 1 to 1. So it's all the same size. But in stone, it actually can be done. And this was done actually specifically for Stanford approval. First, because they wanted to see how it's going to look. Plus, beside that, that was also a sample of carving done. The hand of Benjamin Franklin, like this, but in full scale, the real scale, in Carrara marble. And after that, after approval was granted, so we started this work, and work was finished in 2016, and it's installed. It's over the Wallenberg Hall, and I hope actually not too many people even know it's recent work because, well, first of all, actually it's a little bit far away. It's about like 40, 50 feet away. You don't really even see details which one over there because it's like third floor. But people did pay attention to it and did have close observation what was on the ground before the installation, and that's a good example of preserving past for the future and doing it now at present time. We did carve statues in Carrara, Italy, specifically actually in Pietrasanta. Pietrasanta is considered to be, it's a small town, it's close to Florence, and actually where Michelangelo was working, he was doing his Pietà, his first piece when he was 23 years old, and that's where actually a lot of famous sculptors do their work in stone, specifically in marble. Yeah, it was carved in Italy, and then we shipped it here and did the installation here. I was doing the carving specifically focusing on final stage, finishing it. But besides that, I did use qualified labor and help from local stone carvers, Italians, that were involved in this project. And also, Benjamin Franklin was done in old traditional way, enlarging it with calipers and measure tools. But for me, it was first time I wanted to try today's technology. Johann Gutenberg, we used 3D scanner to scan the model. Then it was cut out on CNC machine. But CNC machine actually leaves kind of a noticeable marks after its own tools. And the finishing anyway was all done by chisel, by hand. So if you even like look at them close on real thing, when they're close to you for observation, both of them they finish by hands, and you don't see even any difference, and you don't see presence of machinery. Machinery just was used just to try to see how it works. Both statues, by the way, they were done from same block of stone. That block of stone was 23 tons, and specifically because the statues kind of relatively close to each other and kind of like I don't know, two sisters or two brothers from same block of stone, some kind of a connection for me. Only two were recreated. The one more, which one over the mass corner, that's actually original one, 125 years old. That's original, still be there, yeah. And this one, they are kind of a new, fresh. I did provide technical assistance on that project. I don't really know reasons. Well, because it was installed in one time, but we live at different times. And recently, actually, a lot of historical figures lost their pedestals. So I guess this was one of them, because I think actually he doesn't meet today's Stanford policy, and he has something his past Stanford would not be proud today. Well, it was actually a lot of people here, a lot of cranes when we were doing that. I was just involved more kind of like a consultant, plus we wanted to be sure by removing it so we don't damage the building, because we didn't know, for example, what kind of anchorage it has. It did have some anchorage on the back, which one was between the marble and sandstone wall. That was actually easy to remove, but we were not sure what's on the bottom, is any anchors between the pedestal and marble. But we did actually use a ground radar. It's kind of like extra ray machine to find out if any metal anchors over there. And we found, yes, there is some metal, there is something. But because it's significant depth, we couldn't see exactly what it is. And we didn't know, but with extra precautions, as careful as we could, we started lifting up the piece. And after we removed it, we actually realized, yes, there were some metal ties, which one actually were holding two pieces of sandstone pedestal together. I don't know, perhaps something happened to pedestal during the earthquake or whatever, but those ties were not connected to the marble. So all removal actually was nice and smooth. We didn't have any problems. We removed it in vertical position, the statue. Then we brought it to the ground. We put it down, lying down. Then it was created, and I believe it's in possession of archaeology department right now. Yeah, somewhere in the crate. And for future generations of stonemasons, what I would suggest them, we try preserve past for the future generation, and beauty is everlasting and thus is for a time. Do your best and protect it for the future generations as you can, and be careful, go slow, measure 7 times and cut only once, but it should be right cut.